Assalamualaikum and hello everyone. My name is Muhammad Amin Zaid Rusdi and my student ID is 2025394889. And for today assignment 1, we will be analyzing the BO time complexity of an iterative algorithm, which is the insertion sort. So without further ado, let's begin. So to begin, let's define the algorithm and its parameter. So insertion sort is an iterative algorithm that builds a sorted array one element at a time. So it works by taking an unsorted item and inserting it into a correct position within an already sorted position of an array. So the input requires an unsorted integers and the output is the exact same array that is modified in place and sorted in a ascending order. So here is the complete Java implementation of the algorithm. So as you can see, it relies on two nested loops to traverse and shift the element. It completely solves the sorting problem with no syntax or logic error. So to fulfill the execution requirement, let me just quickly run this live in VS Code. So as you can see here, I am passing around an unsorted array of 6 numbers, 5, 2, 4, 6, 1, 3, and we will click run. So now the terminal successfully output the modified array that is perfectly sorted from 1, 2, 3, 4, 5 and 6. So the algorithm executes itself and perfectly with no runtime error. So now that we have verified the execution, let's break down the mathematical working step to determine its big O complexity. So first we look at the outer for loop, and this loop acts as our baseline traversal. It starts at index 1 and runs up to n-1, where n is the total length of the array. So because this loop must execute exactly n-1 times regardlessly of what data is inside the array, the time complexity for this outer loop is strictly linear or O(n). Next, we analyze the inner while loop, which handle the shifting. So the complexity here depends entirely on the state of the data. In the best case scenario, if we pass in an array that is already sorted, the condition key that is less than array j will immediately evaluate to false on the first check. So the loop skips entirely. Because no shifting occurs, the inner loop runs in a constant time O1. Therefore, the total best case complexity remains at O(n). However, big O analysis focuses on the worst case scenario. So the worst case happens if the array is in reverse order. So in this scenario, every time the outer loop pick up a new element, the inner loop has to shift every single element that came before it. So on the first iteration, it makes one comparison and shift, and on the second it makes 2, and on the k iteration it makes k comparisons. So to calculate the total operation, we sum this iteration, which is the sum of 1 to n-1. So this form an arithmetic progression, and the standard formula to find the sum is n . So this will form an arithmetic progression. The standard formula to find the sum is n multiplied with n-1, that is divided by 2. So if we expand this equation, we get n the power of 2 minus n divided by 2. So in the asymptotic big O notation, we drop the lower order terms, which is the minus n, and we drop the constant, which is the division by 2. So this leaves us with n the power of 2 as our dominant term. So to conclude, the worst case time complexity of iterative insertion sort is O(n) to the power of 2, while it has a highly efficient O(n) best case and requires O1 extra space. The quadratic O(n) the power of 2 growth rate makes it inefficient for large and randomized dataset. So that concludes all of my analysis, and thank you for watching.